Hello everybody, this is Joshua Phillips for Living Reason. This is part 2 of the 12 balls problem. You can see some brief details on the problem. There will actually be a part 3 where I talk through some of the thought process of getting the solution. But this video just covers the solution I found to the problem. So first, a brief recap. We have a balance scale we're only allowed to use 3 times. And we have 12 ball bearings that are all supposed to weigh the exact same, but we know that one of them is either a little bit too light or a little bit too heavy, and only using the scale up to 3 times, we have to find a method that will always find the defect and whether it's too heavy or too light. So there are basically 2 cases. So my solution, the first step, is that we take our balance scale. If any of my previous art teachers from elementary school were watching, I'm very, very, very sorry. So we take our balance scale and we put 4 balls on each side of the scale. And importantly, this means we're putting 4 balls. Let me use a slightly bigger font for this. So we do 4 balls on each side of the scale, and 4 balls are sitting just off the scale. We're allowed to, we never said you couldn't do that. Now, the first case to think about is, let's say the scale balances. Well, if the scale balances, then we know all 8 of these are fine, and one of the 4 floating off to the side is the defect. So we have to think of how to get from this step with only 2 more usages of the scale to get from there to figure out which of the 4 is wrong and what's wrong with it. Now here's something that works. We'll take our balance scale here. And now we're just going to take one of these balls off the left side, and we'll leave 3 of them on there. And on the right side, we'll take all 4 of the balls off, and we'll place 3 of the ones that were not on there before. That's right, so this one ball is still over here. We have 4 new balls that are over here. We have, let's see, switch to my font again. So we have 3 balls on the left side. We have 3 balls that were sitting out the first round on the right side. And we moved all 4 of these balls off the scale completely. Now, one of 2 things will happen. Either the left side of the scale will go down, which would mean one of these 3 new balls is too light. Sorry, 3 things that could happen. Either the scale could go up on the right side could go down, or the scale could still be balanced. Well, if the scale's still balanced, that's really easy. We know the one ball that hasn't been weighed yet is the defect, and we'll just compare it to one of the balls on the left that we know is good. If the ball we haven't tested yet goes up, it's the one that's wrong and it's too light. If it goes down, it's too heavy. Now, if the scale, and it's symmetrical, so we'll just do if the right side goes up. You can work out on your own the symmetry of if the right side goes down. So if the right side goes up, that would tell us one of these 3 balls on the right side is too light. So we have 3 balls, one of which is too light, and we only get to use the scale 1 time. And the solution, how to deal with that problem, is that we will take one of them and just move it off the scale, and we'll flip the other one over to the left side. So we'll have 1 ball on each side of the scale. And you can see that, if this is symmetrical. If the right side went up, whichever one of these 2 goes up is the one that's too light. If the right side went down, whichever one of these two goes down was too heavy. So there's a symmetry to the problem. So that covers, again, both cases when the first step is that you put 4 on each side, 4 sitting off, and it balances. Now the second case, and I need to do some erasing here. Wrong color. So the second case is if we put 4 balls on both sides. And again, there's a symmetry here, so I'll just cover half of it. Let's say we put 4 balls on both sides, and the left side goes down. So therefore, the right side went up. So again, we have this, I think, is the hardest bit of the problem to work out. So in this case, we know either one of the 4 balls on the left is too heavy, or one of the balls on the right is too light. And again, there's a symmetry if the right side had gone down initially. You're welcome to work out on your own how the symmetry works, but the solution principle is the same. So the very interesting catch here, after this step, these 4 balls that aren't on the scale, we know these 4 are good. They're the correct weight. We're going to need that in a second. So what we're going to do is we're going to move 3 of these balls on the left. I'm sorry, let's do it this way. 3 of the balls on the right, we're going to take off the scale. So they're going to end up, so 3 of the balls from the right end up over here. The 4th one stays on the scale. Draw my scale in. And on the left side, we're going to keep one of the balls on the left side. The other 3 balls on the left side, we're going to move over. Sorry for my artistry, everybody. So we're going to move 3 of the balls on the left side over to the right side. And we'll take 3 of these balls that we know weigh the right amount, and we will place them on the left side. Now, a couple different things might have happened. If the left side of the scale stays down, since we moved these balls on the left side, now they're on the right, it can't be that they're heavy. And since these 3 are we're already confirmed to be balanced, the only candidates are these 2 balls on the end. So either this far left ball is too heavy, or the far right ball is too light. And that's easy to solve from there. We can just take the far left ball, compare it to our 4th one we confirmed in the first step. If the far left ball goes down, it's too heavy. If the scale balances, the far right ball was too light. So if the scale doesn't change, that's pretty straightforward. There are only 2 candidates, and we have, a control ball, as it were. In the second case, what do we do if the scale balances now? Well, if the scale balances, then one of these 3 balls that was initially on the right side must have been too light. Since we know what's wrong with it, we can solve that one in one step. And what we do is we take one of those balls and place it on the left side of the scale, and we take another one and place it on the right side of the scale. And so, if either side of this goes up in step 3, that's the one that's too light. If it's balanced, this 3rd ball is the only one that would have led to the right side being up in the first step, balancing in the second step when it was taken off, and balancing in the 3rd step when we check the other 2. And then by symmetry, or by a very symmetrical idea. So I'm just going to erase this for space. If the left side of the scale, the right side, if it balances one of the ones we took off is good. If the right side of the scale now goes down, then that tells us one of the 3 balls that was moved from the left side to the right side was too heavy. So we do the same thing with these 3 balls. We put one on the left side of the scale and one on the right side of the scale. And this time we know that the defective one is too heavy, so if the left side goes down, that ball's the heavy one. If the right side goes down, that ball's the heavy one. And that would be these 3 right here we're talking about, by the way, not the 4th one. So this one goes here, this one goes here. Whichever side goes down, that's the heavy one. This 3rd one gets taken off the scale, and if the scale balances, this one's the heavy one. So thank you to everyone watching. I might make a 3rd video at some point where I talk through the process by which I found the solution of the problem. And again, I sort of left as a homework assignment what to do if in the first step, instead of the left side going down, the right side goes down. And again, at the beginning of the video, we covered the first step, balancing. So thank you to everybody watching. Please ask any questions you have, or if any part of my explanation wasn't clear, please tell me. I'll try to add some annotations in if YouTube still allows that. If you enjoy my videos, please share. I appreciate all the support. Thank you very much, everybody, and have a nice day.